Rewrite the expression sine of tangent inverse of x in terms of x only. With many of these problems, we let the inverse expression be theta, let tangent inverse of x be theta. If we were to use inverse tangent, we have to restrict the domain from negative pi over 2 to pi over 2. This is where theta should be, not including the endpoint. We then rewrite tangent inverse of x equals theta as tangent of theta equals x, but only if theta is in the restricted domain negative pi over 2 to pi over 2. We then use the right triangle to set up the ratio. Tangent equals x, but we can rewrite it as x over 1. Using the generic right triangle, we label theta. Tangent is opposites over adjacent, so we would label the opposite side to theta as x and the adjacent 1. The missing side is the hypotenuse, which is 1 squared plus x squared, and then we square root it. The question is now finding sine of theta, where theta is tangent inverse of x, using this right triangle. If somehow we can find sine of theta, then we are done. First, sine of theta is the opposite x over the hypotenuse, the square root of 1 plus x squared. But every time we use the right triangle, we would need to have a plus or minus. Observe that in the first and the fourth quadrant, in the first quadrant, cosine of theta is positive. In the fourth quadrant, cosine of theta is also positive. In the first quadrant, sine of theta is positive, whereas sine of theta is negative in the fourth quadrant. And similarly, tangent of theta is positive in the first quadrant, and tangent of theta is negative in the fourth quadrant. So the sine of tangent of theta determines the sine of theta. Sine of theta and tangent of theta have the same signs in the first and the fourth quadrant. The fact that we were given x can be any number, positive or negative, take care of the sign. If theta is in the first quadrant, then this x has to be positive. And if theta is in the fourth quadrant, then this x is a negative number. But again, itself is a negative number, which is the signed number already. We don't assume that this x is positive. And so, because the sign of tangent also determines the sign of sine theta in the first and the fourth quadrant only, we conclude that sine of theta equals x over the square root of 1 plus x squared without having to write plus or minus, because this x can be either plus or minus, positive or negative, depending on where theta is already.